Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Isham bin Muhammad Azharan. My metric number is CN210113. Today, we from Group 8 want to present about development of advanced electrode and electrolyte for lithium-ion battery. Okay, this is our team. The first is Nur Hakimi Akmal. The second one is Muhammad Isham. The third one is Iskandar Dizulkarnain. And the lastly is Muhammad Asif. Okay, next we go into the introduction. A lithium-ion battery have become the most competitive battery type in the world due to their high energy density and superior storage capacity. The, they have electrode and electrolyte that make up a suitable lithium-ion battery. Okay, next we go into the traditional graphite anode and cathode material have several flaws that must be addressed because of its high quality, good reversible and low cost. Graphite is the utilized commercial electrode material in anode and has a low energy density because it can only retain one lithium atom for every six carbon atoms. Okay, the standard lithium-ion battery is the metal cobalt, which is strongly tied to the cost of the battery and cause significant environment impact. Furthermore, worldwide cobalt prices are very variable, and which is makes time grow of lithium-ion battery as well at the market for electric product and automobile.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Hakimi Akmal bin Nur Helmi. My metric number is CN210008. So today I will talk about the current or existing technology. So based on my project, that is a development of advanced electrode and electrolyte for lithium-ion batteries. So in this chapter, I will share about technologies working principle, import technologies, and last one is implementation of existing technologies. For the first one is the technology working principle of the lithium-ion battery. So for the first one is in the battery there has anode, cathode, separator, electrolyte, and two current collectors. Then from the separators, the electrolyte will transport positively charged lithium-ion from the anode to the cathode. After that, the mobility of lithium-ion in the anode generate free electrons, which is generate a charge positive to the collector. Then the electrical current pass to the current collector to the negative current collector via power device. That is such as a cell phone or any electrical device. Then the separator will prevent electron from flowing within the battery. So when the battery is discharging and providing electric current, they are not release lithium ions to the cathode, generating a flow electron from one side to another. When plugged in the device, the opposite happens. Lithium ions are released by the cathode and received by the anode. So from our project, our project is changing the anode from graphite to silicon. So these are the companies from United States that has developed the silicon anode lithium-ion battery. So for the first one is Innovex. Innovex is a manufacturer and developer of innovative silicon anion-based batteries. So there has a 3D cell architecture that produce the lithium-ion battery. Then their patent pending the 3D cell architecture. So and the current collector vertically in a flat composition. This architecture has the remarkable advantage of enabling high capacity silicon anode and improving spatial efficiency to increase energy density. So for the next one is Amprius Technology. So this company manufactures lithium-ion batteries with greater energy density than typical lithium-ion batteries. It also collaborates with OEMs to create splash batteries for consumer. Then Amprius has built a comprehensive technology platform that represents the entire battery ecosystem. Amprius provide innovative lithium-ion batteries such as silicon nanowire batteries that are specifically designed for autonomous and electric vehicle design and defense and mission critical wearable. So for the last one is the implementation of existing technology. So for the technology is a lithium-ion batteries. So the implementation for the number one is the Lion Best Market Overview of Europe Middle East and Africa is presented. So a lion-based mean a lithium-ion battery energy storage system. So for the second one is existing lion-based use cases are analyzed. Number three is the key driver enabling the implementation of lion-based project are discussed. The fourth one is the requirement and associated risk factor are evaluated. And last one is the future relevant technology development and market trends are assessed. So for this implementation, they can solve the question that have been around the world, uh, such as uh, what are the primary application for large-scale lithium-ion battery that are being developed, then the critical factor enabling the adoption of best project into this market, and the last one is the present trend to extend the future of Lion Best. So that's all from me. Thank you.
For implementation, for 3.1 implementation of the project, the Malaysian government improved industry policy of FIs. For second point, the Malaysian government must providing greater incentive. For 3, people degrees of consciousness. And last but not least, the government as well as car seller introduce of EV vehicle in Malaysia. For 3.2, 3.2 is the company in Malaysia that can collaborate with our team to execute this project. We have two companies that were suggested. First, we have Koyoko brand, and second we have ABM Fujiya Berhad. As we know that Koyoko brand is the most famous brand battery in Malaysia. It is located in Pulau Pinang. And Koyoko brand most familiar with the motorcycle batteries. Then for ABM Fujiya Berhad is located at the Sarawak. It is familiar with the cars and lorry for this consumer of the battery. For 3.3, ways this project can be support our NAP 2020. First, we have this project will be promote the application of environmental friendly new technology element in the line with Malaysian commitment in United Nations Framework Convention of Climate Change UNFCCC. Second, we have Malaysia will be able to market its automotive good on worldwide scale if particular step to boost technology development in NXGV, MAS and IR 4.0 in the domestic automotive sector are implemented. For point number 3 is provide new opportunities will focus on only the automobile industry but also on the service sector which have been prepared in the mobility ecosystem. And last but not least, the next generation of electric car batteries will be increased range and safety emerge in the form of lithium metal and solid state technology. For next.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iskandar Zulkarnain. My metric number is EN210035. So today I'm gonna tell about environment and sustainability. Okay. In this part, we have two things, which is explain how this project can contribute to our environment and sustainability. And second one is describe the benefit in terms of CO2 saving. For the first part, which is how this project can contribute to our environment and sustainability, many modern electronics use lithium-ion battery, including perhaps most importantly from an environmental standpoint, electric vehicle and energy storage system. Technological investment has made a lithium-ion battery with higher energy density more affordable. Batteries are also crucial in the transition of our transportation and energy sector away from fossil fuel and toward clean renewable energy. Second one is, while lithium-ion battery aid in the promotion of many sustainable action, It is important to note that the batteries themselves are not yet environmentally friendly. When compared to the alternative of using fossil fuel, lithium batteries are outperform. Even better, researchers are working to develop more environmentally friendly battery technology. Next, lithium-ion batteries also can be recycled. Unfortunately, only 5% of lithium-ion batteries are recycled at the moment. Our country expect and predict that between 2017 and until 2030, approximately 11 million tons of lithium-ion battery will be discarded, presenting both a significant need and opportunity for recycling programs. Recycling has traditionally been costly and time-consuming, but recent advances may change that. As you can see, this is the picture of Nissin EV Tech Sdn Bhd, a wholly owned subsidiary of Nissin Sdn Bhd, has entered into a strategic collaboration agreement with Sirim Berhad to establish a lithium-ion battery recycling plant in Malaysia using a public-private partnership funding model. Both parties will also work together to create an ecosystem for a circular economy model in order to reduce the environmental impact of lithium-ion batteries being processed illegally in our country, which is Malaysia. Lastly, working with the government, the company will establish a lithium-ion battery manufacturing plant in the country and implement a lithium-ion battery recycling policy. For the next part is the benefit in terms of CO2 saving. As you can see, this is the table based on the study that have been done on the Zahirich battery. A total of 3,772.72 kg of CO2 are released when you procure and purchase a new battery. Other than that, in terms of CO2 saving, it depends exactly where and how the battery is made. But when it comes to clean technologies like electric car and solar power, even the dirtiest batteries emit less CO2 than using no battery at all, because of the amount of energy they can store in a small space, charging capability and ability to remain effective after hundreds, if not thousands of charge cycle. Lithium-ion battery are popular power source for clean technology such as electric vehicle. These batteries are an important component of current effort to replace gas powder vehicle that emit CO2 and other greenhouse gases. Last but not least, this comes at a cost, as the production of battery and the component emit CO2 among other environmental and social concerns. That's all from me. Thank you.
For the conclusion, in general, development of advanced electrode and electrolyte for lithium-ion battery caused by repeat charge-discharge cycle have been made, include the design with the different structure, the development of new binder, and the combination of carbon material to form matching material. In summary, this particular value cannot be ignored because this stage is still being explored and still being explored and they have great development potential in future. That's all from our group. Thank you.